Hello, so it's actually about 4 months since the last video on Menace. I think the first and second episode of this series was actually recorded in spring this year, and it's now getting on for the end of summer. So it's been quite a long time. I haven't been able to get around to this, and as you can see, I'm actually working on an emulator now because I don't have an Amiga with me at the moment, but I decided to push on. So in the last episode, I was trying to get all this Amiga format code to compile. There's all the disks and stuff that I've got. So in DevPack, basically, let me boot up DevPack. So, and I'll show you what I've done. I'm basically back at where I was at the moment, but so what I've done is I've taken the latest source code from the Amiga format disk, the last one that they did, and I've taken the NDK, the Amiga NDK for 3.2, which is what I'm running on this emulator, which is also what I'm running on my Amiga. And I've just tried to get it to, first things first, I'm just getting it to compile in there. And there's a few things that I had to do. So one of the first things was I had to put this sysspace thing in here. This thing. This was in one of the versions of the code, but then the later one just removed it. So it just uses this sysspace, which is just at a constant of 4, which is the address it needs to get the exec library. So I just had to put that in. And the other thing was that it wouldn't actually compile this exec lib file, and I'll show you why, because it's got a macro in it. And if I open it up, here's the NDK, and these are the includes for assembler. It's in exec, and it's exec lib. Basically, yeah, it's got all these like offsets to these functions that are the library functions, basically. For the OS, and they're all defined as this macro. Now, the problem with this is, and I think this is something you don't get nowadays, is they couldn't actually define the macro for this, which is just sets a load of offsets for these functions. They couldn't define it in these include files because there was no actual like standardized macro syntax for these assemblers. So there is an example, but obviously they don't actually give you the example. The example's actually in libraries.i. Where is it? It's basically just looking to, this is it here. They give you an example. FuncDef is used to parse library offset tables. Many applications need a special version of FuncDef. You provide your own macro to match your needs. And here's the example. And the reason why they've commented that out, and the reason is because it's not guaranteed to compile on your specific assembler. So it's left commented out, and I did find a page online. I'll put a picture of that in here that was actually explaining how this works. And I don't think this one would actually, yeah, this one wouldn't actually assemble. So I've done my own, and even the example on the page wouldn't compile, it wouldn't assemble in DevPack. It almost would. So I've created in the Menace folder, basically I've got the source code. I'm calling it Menace fixed, but there's nothing fixed yet. I created this funcdef.i, and that's my version of the macro. The difference between the one on the webpage that I found and this one and in DevPack is it wants the label of the macro before the word macro here, and the other one had it afterwards. So this is saying funcdef is the label, and then the macro directive comes afterwards. And this macro here is basically just trying to set LVO_LVO with the name of the macro, the name of the function, and then it's just setting it to a certain value, and they're incrementing each one. So basically that's it. So what I've had to do is include that gets around my compile errors, and add that, and that gets around the compile errors on this because it wasn't defined. So that's all I've done so far. And this the other thing is I had to, in the assembler control here, this is the default. It just says headers is where it's looking for this system.gs. Those GS are just pre-compiled headers to speed things up. So I've actually had to create a bunch of settings that tell it to get the NDK 3.2. And that is, I'll load those settings here. It's not much different. It's in settings, assembler control. All it is I'm just saying, hey, there's my 3.2 assembler includes. Just include those, please, and then find all those for me. And I think the last change actually was, yeah, the other change I had to make was there was just a colon in front of there to try and, I think they were just putting it in to make sure that you knew to put path to it. I just took the colon out because all these files are in the same folder that the source code is, and I had to compile, get the foregrounds, map and panel from the other older episodes and put them all into the latest one, because it didn't give you every file in the latest one. I think that was just to save space on the disc on the front of the magazine, because they only had 880k, so if they could just not give you something that you'd be giving you in a previous episode, that was probably going to do all right. So with all that, just those changes there, this now assembles with, let's just see if it works. That basically assembles with just the NDK 3.2. That's all I've changed. Really, the source code is the same. I've just made it compile. It won't actually run from here. Oh, it does run. There we go. So there we go. And you can actually control this with the mouse. Somebody mentioned this in the comments of the first episode. You can control the shit with the mouse. I'd either forgotten that or didn't know it. And it looks like, you see these blue lines? That is actually the sprites, the enemy sprites loading. But it's all corrupted. So we're back where we were, except I'm compiling with NDK 3.2 and I'm working on an emulator. Also, this doesn't, I think that's another alien that's appearing. You see there's yellow stuff on the screen. I can't find a way to exit this. I don't really know how you do it. You can't press escape. Not sure. It'll just crash when it ends. If the ship blows up, I think it just crashes. Yeah, it just crashes. Normally it says suspend there, but it hasn't actually done it here. So that's not so bad. I've got something working. I did try just taking the executable that this made. You could say assemble to disk. Yeah, so that is the executable that was built in DevPack. And I did take that and I ran it on the emulator in Workbench 1.3, and it ran absolutely fine. I actually don't think I did the one I compiled. I just did the one that they gave you. They gave you a compiled version of it on the disk. So that actually ran fine on 1.3. It actually ran fine on Workbench 2.05. I tried it on that as well. I think that was with the 1.3 kernel though. That ran fine, and I switched that in the emulator to a 68020, and it actually had some glitches, but it wasn't the same as what we're seeing there. So the things that are going wrong is all to do with basically Workbench 3.2 and the new kernel, which didn't exist when this was made, so that's kind of understandable. So I think the next step is, I suspect that much of the code in here might be okay, but the fact that sometimes when I ran it before, sometimes it would start up and it was okay and sometimes it wasn't, makes me think that the actual system takeover code isn't working properly in this. And there is a function in here which I found called TakeSystem, which it calls pretty much straight away, and it's not much code at all. I mean, this is covered in the magazine, but this is the code. It's just these few lines here. It's just this little bit of code here, which is supposed to take over the system from Workbench. Now, I suspect that this is part of the problem here, because I don't think this is good enough for, well, what we basically need now. And maybe you just get away with it on Workbench 1.3, but maybe we're not here. I don't know, this is a problem, but this is definitely the first place to start, because this isn't going to work correctly. Now, what I have got is the Bare Metal Amiga programming book by Vanden Oosterkamp. I don't know what his first name is, but this has got a section in here just about doing this system takeover, starting and stopping safely. Now, first thing is, if you're running from Workbench, you need to wait for a message from Workbench and then reply to that, okay? Or save the message so you can reply to it later. Right? That's not happening. So there's the first thing. You then would need to call the exec forbid function, which stops Workbench from paging in or swapping in new tasks. That's not happening. So it could be that Workbench is actually swapping in a new task after we've started taking over the system. The next thing that could be a problem, this here, where it's doing this save the interrupt vectors, these ones here, on the 68,000, which is what this was programmed for, the CPU vector base registers were always offset from 0. So I think the 68 is just 68, as in a 68 offset from 0, so just 68, which is where the interrupt vector can be stored. But on the latest processors, It doesn't have to be at 0, so you have to query where it is. Now, this isn't doing that. If we're getting lucky, then the vector base register is at 0, but if it's not, this code doesn't work. So that's definitely a problem there. So we're not waiting for the system, we're not stopping processes, we are not using the vector base register properly, the CPU vector base register. And other things are, what else have we got? I think we need to, I'm not sure if we have to wait for the blitter to finish as well. Is that something we have to do? I'm not sure. There is a wait in their version which waits for 2 frames for something. I'm not sure if that's waiting for the blitter to finish. So there might be something wrong there. And then also their code then eventually then disables the DMA and stuff, which is what this is doing here. Oh, they're disabling then saving them. But they should probably save them then disable them. I don't know if that's right. And then they return from here and start the actual program. And basically that's all happening in reverse at the other end. So, you know, when they come back from system. But if we can get this first bit right, then, well, we'd have to get the free system right as well. But we don't need to get that right now. So I think that's my next step. Is there is actually with this Usercamp book, they give you a safe startup file that you can use to start up your own programs. But it might be worth trying to fix this one first, just to, you know, see if we can do it. So what I want to do is fix up this TakeSystem code, see if we can actually take over the system correctly, following the guidelines here. But yeah, this definitely would have probably worked. Well, it did work in, you know, for the 1.3, but it's not working so well here. I suspect maybe part of what's wrong is just this. Let me get to it and I'll start fixing this code up. And oh, it's got kill keyboard. I don't know if that's in their version. I'll fix this code up and then we'll run it again, and then we'll find out if we've got anything better than what it's got here, which is, oh, just crashing now. That just crashed out instantly. Looked like it crashed. Yeah, so we need something a bit better than that. There it is. Yeah, I think what's happening is that the blitter and stuff and the interrupts are being written over after we've started taking the system over. This is probably indicative of one of the problems with the, you know, when the Amiga, when the A1200 came out, is that anyone who was taking over the system like not correctly made this incompatible. But in theory, I think a correct system takeover done back then should have worked on the A1200, but it's just not quite good enough. I mean, it is a few lines of code, that's all. But so yeah, let's fix this and see if we can get this thing, see if we can get it to work any better. We might still have more problems. There could be some problems with the 68020 possibly, but if not, let's start with that and work our way up from there. So I'll come back to you when I've implemented some code in this TakeSystem, or I'll rewrite TakeSystem basically. Okay, so this is just a bit of a, well, it's a time lapse of me implementing a better startup routine. And what I'm doing is I'm just following along with the bare metal Amiga programming book by Van den Oosterkamp. And there's the whole section, it's right at the end strangely, which is starting and stopping Workbench safely. So I'm just trying to re-implement what they've, what he's done there into Menace, just around where the TakeSystem is. And I'm actually having quite a lot of trouble with it because one of the things that's gone wrong is, well, firstly I was doing it on the emulator and I couldn't even find out which is the right Amiga key. Turns out it's mapped to home, don't know why that is. And I was just trying to implement the bare minimum to get it working, and I wasn't implementing it exactly as they'd said. So I changed some of the registers that were being used for the TakeSystem because I thought the registers that was being used didn't matter too much. Turns out I was wrong, because one of my big problems was I'd written over the A5 register, and Menace itself had set the A5 register just before it called TakeSystem and was using it for something. So writing over that was screwing the rest of the game. And then also I'm calling into the graphics library, and I decided just to use the A5 register because it was free, but then I found out that you can't use the A5 register, because when I stepped into the function using the debugger, which is Devpack's got a debugger built in, I saw it using the A6 register, and I was like, wait a minute, but I've not set the A6 register to what it wanted. So it was just something I didn't know, so it was a total noob fest going on here. And basically this took me hours to get anything going here, and as you can see, I'm just like it's just gone completely wrong. And then there's a part here where I thought, wait a minute, it's working. You know, I've got like the it's working, and it just wasn't really working because this was just a total fluke. That sometimes the startup code can start up and it works, just depending on where you start up in the frame or where the scan line is at the time, possibly. So I was like, yeah, I fixed it. And then after this, I found out, no, actually, I've not fixed it. I've actually just made a complete mess of this. So the time lapse will carry on here. And yeah, it was still broken. So that's where I was up to. I was just basically trying to get this going. Loads and loads of software errors. So here I am at the end, and after much messing about, I have managed to finally fix the startup and shutdown routine in Menace. So I'll just assemble it here and we'll show you it working. So it's not fully working, but it's a lot better than it was before. So if I run this now, there we go. Now notice that there is still some graphical corruption here, but it's reliably starting up each time. And the other thing to note is the collision detection isn't working. So yeah, it does start up correctly, but it's just, yeah, it's got corruption. It looks like it's got some corruption that's on the foreground playfield, because there's two playfields here. Looks like the main playfield has got some corruption on it, but also I think the background's got some corruption on it as well, the background playfield. So it's a bit crazy. I don't really know how you're supposed to get out of this, other than if you die, it just quits, which it does quit successfully now. It takes me back to Workbench and everything's still working. It's actually working. So let's just go through what I did. Basically, I'm following through the Oosterkamp safe start routine that's in the book, but I'm adapting it for Menace. Basically, I'm just adapting it into what they've got. Where's my TakeSystem? Here it is, down here. So it was called TakeSystem, their version, and I've renamed the original one, and I've just started in a new one. So the first thing I did was save a few registers onto the stack, and that's because I realized Menace was using A5 register, and there's a couple of registers I was using as well, and I was starting to get paranoid that Menace was using those as well, because I saw it had loaded something called variables into A5, so if I didn't restore that later on, it was breaking everything. I also needed the sysbase pointer in A6. What else have we got? So this is stuff that was recommended from the safe start routine in the Oosterkamp book. We need the pointer to this task, or the process data structure, to find out if we're running from the command line or if we're running from Workbench. If we're running from Workbench, we have to save a message for later and reply to that when it finishes. So I don't really know if that's working, because I think it's running by the command line stuff here. And this proc CLI is defined up there, and that came from the safe start thing. And I think there should be in the Workbench includes, there should be like an include for that somewhere, but I don't know what it's supposed to be called. Some of the ones I have actually changed to the proper Workbench ones. We call the exec function to stop any tasks from being run. So once you do that, nothing's going to work, including the debugger, as somebody pointed out, which is true, but I did manage to use the debugger to good effect. This is the next thing here. This part here, find VBR. This is something that wouldn't have made any difference to Menace at the time, but as soon as the 68010 and later processors came out, they can move the vector base register address, which is always 0 on 68000, but can be moved on later ones. So you have to look up where this vector base register is and store it. And the funny thing is you can't actually just look at it. You have to call this supervisor routine with a pointer to the interrupt function that just loads the VBR and then into D0, and then it just comes back. And where did I put that? There it is, store VBR. So it's just got this move C, and it's the VBR register into D0. Now once I do that, then I have to change it to 68010 or 68020. I've set it to compile as 68020 code, which shouldn't make too much difference, but just that line of code makes it incompatible with the 68000 now. What else happens after that? This is the bit that was really, I think this is the bit that really fixed it, is we load in a null view for Workbench, and the null view is basically I would say the copper list that the Workbench is running, and possibly a few other things. But by doing this load view with A6 is nulled here. Sorry, A1 is the view that you're loading. A1 has been nulled. So by calling load view, which is in the graphics library in A6, with null, that just basically like gets rid of the copper. But the copper list is still running, and because the copper list is like timed with the screen, you have to wait for, this is wait top of frame, I think this means. So it waits for the top of the frame twice because you want to wait for the copper list to end, and it can be an interlaced screen, so you want to wait for the other interlaced screen's copper list to end as well, so you wait twice. So if you're not in interlaced mode, you'd get away with one of these, but this is just in case Workbench is in two. And then this next part, this is very similar. I just adapted this to what Menace was already doing. It's saving the system interrupts and the system DMA, and except I'm just setting the set. There's a set clear bit, and I'm just setting it to set now as I'm storing them, so later on it makes it easier. This is also something that Menace wasn't doing. It's waiting for the blitter to finish doing something. There's a blitter busy bit that you can check, and it waits for that twice. For some reason it's got a dummy read. I think they, in the safe start, said that NTSC requires a dummy read before you actually check it. And here's the thing that was odd to me. It's bit testing here, BTST, bit test byte, with the DMA, that's DMA control, and it's the read register, that's what the R stands for, DMA con R. And it's like 14 minus 8. And it's like, what's all this 14 minus 8? Well, it's bit 14, but of course we're checking a byte only. And because the 68,000 is big endian, the high end is stored first, the big stuff stored first. So they're subtracting 8 to get to bit 14 of the high bit of DMA con R. So that just reads horrible, but really it makes sense once you know what it is. But I think knowing that the 68,000 is big endian makes that work. I don't know if there's a bit test word, and you could have just tested a bit test W with bit 14 and that would have worked as well. But they've decided to bit test byte. We could try that now actually. Is there a bit test word? Let's just see if that assembles. No, it does not. Just invalid size. So there is no bit test word. There's only bit test byte. Okay, so that's why they've done it that way, but that reads really horribly. Yeah, so that's what that 14 minus 8 is. It's just saying I want the 14th bit. So there you go. And then I restore from the stack. I restore those registers that I'd used, and that restores Menace's A5 register and the other couple as well, just in case. Now this hit down here, it says TakeSystem Menace. This was originally Menace's TakeSystem, but some bits of it have had to go up here. I think the bits where it saves the DMA and the system interrupts have been moved up there before I wait for the blitter and stuff like that, because that's the order they did it in. But essentially this bit's very similar. Disable all the interrupts, disable the DMA, and save the CPU interrupt vectors, but this time using the vector-based register offset, which could be 0 but might not be. So, and then I return from here, and that's when Menace is taken over. And then the bit down at the bottom is basically all the opposite of that. This free system, again we wait for the blitter again. We get the vector-based register. We restore those vectors. We restore the copper. Well, this is a weird one. Restoring the copper list. There's 2 copper lists, and you restore like a couple of default ones. Restore the system interrupts to store the DMA. Reload the view with the view pointer that we stored before. Oh, and then here's a to-do which I haven't done yet. I need to reply to that Workbench message that I saved, if there was one. So I haven't done that yet. But other than that, this is a successful startup and shutdown for Menace. So I have quote unquote fixed it for Workbench 3.2 and the 68020, or this is set up as an Amiga 1200 basically with 4 megabytes of fast RAM. It is quote unquote fixed, but we do have some graphical corruption and we do have collision detection completely broken. So whatever those are, they're not to do with the system startup and shutdown, I suspect. I think it's something to do with AGA in this case, or something to do with 32-bit stuff. I don't know. But I suppose the thing to start with first is to fix the collision detection, because if that doesn't work, we've not really got a game here, have we? We've got nothing. We can't test the rest of the game. So that'll be in a future episode. But as it stands here, I've gone a small way to getting this working, and I'll start putting this stuff on Git, and I'll put links in the description for that. So if you want to play along at home, you can, and we can preserve the changes to this for future reference. I've saved the original version that I started with, and I saved one of the versions along the way, but as it stands here, all I've done is try to correct the startup and shutdown routine. And to do that as well, yeah, I did have to add a couple of includes. I tried to use their includes where possible. I include the graphics space as well. So there's a few extra changes up there. But other than that, that's it. Doing quite well. Menace is kind of working. I wish there was collision detection. I'd actually be able to play this. So next episode, start taking a look at all this other stuff that's going on. I think it's going to be hard to fix this stuff, but some people might, in the comments, might already, know what's going on here. I already got a few suggestions in the previous episode, and I'd already started this one, but people were suggesting the fixes that I'd already spent ages looking for. So what's going on here, I'm not sure. But I know this game is, when the aliens are moving, they're actually, like it's blitting over the screen, and then it's restoring the screen to what it was. And it looks like that's failing, but it also looks like it's doing it in the background, so no idea what's going on there. I don't think it's an emulate problem. I think if I put this on a real Amiga, it would do all the same stuff. So next episode, whenever that will be, we'll start looking at collision detection on this. I don't know how they've done it. I can't remember. It's actually talked about in the magazine, I think. And we can actually start looking at the game, because I think we've got a successful startup and shutdown, and we'll take it from there. So I'll catch you in the next one.